Okay, in this problem, we've got resistors that are both in series and in parallel. So let's see if we can work out the total effective resistance of this network of resistors. Okay, now the first step is to identify which resistors are in series and which are in parallel. Well, hopefully you can see that R1 and R2 are in the same loop, along the same branch. And so those resistors are in series with each other. On the other hand, resistor 3 is actually in a different branch compared to resistor 1 and resistor 2. And so resistor 3 is in parallel with resistors 1 and 2. So resistor 3 is in parallel with R1 and R2. Okay, so basically the way this works is if you've got a nested series of rectangles in here, for example, we've got these resistors here in the red rectangle, and then of course the blue rectangle is zooming out. What we need to do is work out the innermost rectangles first and then work our way outwards. So the first step would be to work out the total resistance of R1 and R2. And that's going to be easy because they're in series. Anyway, let's give these resistors some values and actually do the calculation. So R1 equals 110 ohms. R2 will equal 250 ohms. And R3 will equal 1000 ohms, or 1 kilo ohm. So the first step is to work out R1 and R2. So if they're in series, so we use the series formula, so RT will equal R1 plus R2, and that will equal 110 ohms plus 250 ohms. And if we add those together, that'll be 360 ohms. Okay? So basically what that means now is that those two resistors, R1 and R2 in here, could be replaced by a single 360 ohm resistor. So I'm going to go ahead and do that, okay, just to demonstrate something. So if I now just erase this, okay, and replaced it with a single resistor, which is 360 ohms, then effectively we haven't changed the total resistance of this circuit 1 iota. Okay, so now we can see that R3 is in parallel with this 360 ohm resistor. And so what we could do, in fact, is work out now the total effective resistance of the two resistors in parallel. So what we would now do is, I'll do this in blue, I think. Okay, so now we're working out the blue section. So because they're in parallel, we're going to use the parallel formula. So 1 on RT. Now, the total resistance here is going to be 1 on R3, which is the resistor down here, plus 1 on 360. Okay. Now R3 was said was 1000, so 1 on RT equals 1 on 1000 plus 1 on 360. Okay. So let's now work those out as decimals. So 1 on 1000 is 0.001, and 1 over 360 is 0.00278. We might just make that 0.28, okay? 0.0028. And if we add those two together, we've got 0.0038. So 1 on RT equals 0.0038. And therefore, RT will equal 1 over 0.0038. So I'll just create some room for myself here. Okay, so therefore RT, so we're looking at 1 and RT equals that, so therefore RT will equal 1 over 0.0038, and that equals 263.16 ohms. So that would be the total effective resistance of this entire circuit. So this battery would actually feel an effective resistance of 263.16 ohms. Okay.